Hey everyone, happy Monday. Monday before spring break. Woo woo. Um, for those of you who are watching this the Monday before spring break, that is. Um, Back into our 3D geometry unit. So I know it's been a bit since we've been working in this, but let's kind of recap where we've been and then where we're going. So we've talked about the basics, we've talked about surface area of prisms, and I bet you can guess where we're going now. We're going to be looking at the surface area of pyramids. So without further ado, here we go. And this is like a rerun of the surface area of prisms lesson. Same concept, same idea, just a different type of shape. So we've got pyramids. Remember, surface area is exactly what the name says. It's the area of all the surfaces. Imagine you had a cereal box and you pulled it apart and laid it out flat. And if you have a box like that at home that you can do it with, do it. It'll help you see what we're even talking about. We're talking about all of the space that has writing on it. That's the surfaces, the area of the surfaces, the area that's filled with like the writing on a cereal box. It's a two-dimensional thing that we're finding, not volume. Anyways, for pyramids, if you can recall, they have one base and then they have a bunch of triangular faces. No matter what type of pyramid it is, all the faces that aren't the base are triangles. And so, what's going to be the work for you is reimagining the three-dimensional pyramid as a flat two-dimensional version of itself. So, to help you do that, we're going to unfold it and unfold it all the way till it's laying flat. So if we were to pull apart this pyramid, this is a rectangular pyramid, its base is a rectangle, and all of the sides are triangles, and that's exactly what it would look like laid flat. So we are going to be finding the area for this particular figure of 4 triangles and 1 rectangle. So let's do that. We've got a rectangular pyramid and we have to pull it apart. Now, you're either going to be drawing the net, and the net would look like this. A net, remember, is if you could pull it apart, lay it flat. I'm not good at that, and I prefer actually to not do nets. Instead, I am someone who draws all the individual pieces and then I put it all together. So the way I would do this is I would draw the base and I'd label its sides. Since it gives me a measure of 7, this is actually a square, so it's a 7 by 7 square. So the area of the base is 49 square meters. And then I've got to pair that, and I can tell that all 4 triangles are the same because if this is 7 and this is 7, and the heights have to be the same because they're all starting at the same point and ending at the same point, so all the heights are going to be 10. And if you can recall, the area of a triangle is base times height, but then cut it in half. So base times height divided by 2, or base times height times 1/2. Either way, you'll get the same answer, and that's going to be 7 times 10 divided by 2, which is 35. But you need to quadruple that because there are 4 triangles. So that's going to get you to 140 square meters. And you're not done quite yet because you need to pair this and this. That's 1 base, 4 faces, and that's going to give you a grand total of 189 square meters as your surface area for this square or rectangular pyramid, whatever you want to call it. I know that went sort of quick, and sometimes you like to see if you can do it on your own. So I encourage you to pause the video and give this one a try if you want. Try redrawing it or try drawing the net. I am actually going to tell you to pause right now. And if you pause, now you're unpausing it. I'm not going to do all the work, but it's a square pyramid, so that means the base is 8 by 8, and then you're going to have 4 triangles that are 8 with a height of 11. Oops, that's supposed to be 11. And if you do all of your math correctly, just for the sake of time, you should get 240 square feet as your final answer. 64 from this, and the remaining portion comes from all 4 triangles. So hopefully you were able to come up with that. The last part of this lesson is going to be pyramids, but when the base is a triangle, so triangular pyramids. So I guess the first challenge-ish kind of challenge is to visualize it. You've got a triangular base, that's the red part, and then you've got the rest of the faces, which are also triangles. Those should be identical. So putting it all together, I'm going to do it where you just redraw. So this is my base, and the base, we're given this measure, and that's important because this is also given to us. That's right here, and that has to be the height because it's going from one of the sides to the tippy point furthest away from it. So the height for this triangle is 5.2. So 6 times 5.2, 5 and 2/10 divided by 2. That's the area of the base. Then you're going to have to do the 3, wow, that's a bad triangle, but deal with it. You're going to do the area of all 3 other faces, which are 6 as the base. I'm pulling that from here. And if that's 6, this is 6, because nothing else is labeled, so we're assuming this is an equilateral triangle. Anyways, the height of that equilateral triangle is 8. So this is 8. So we're going to be doing 6 times 8 divided by 2. And then whatever that is, triple it, because we have 3 of those identical faces. So that's going to be 6 times 8, 48, divided by 2, 24, but then triple it. And then this area should be 15.6. And then in total, grand total, add it all together, we should be getting 87.6 square feet. Square feet because it's 2-dimensional. It's a laid flat figure, and the area of any flat 2-dimensional shape is whatever the units are squared. So make sure you're getting your units correct as well. Cool. If you have any questions, feel free to message us or hop on a Google Meet if it's available to you. For those of you who like to see things and try them on your own, I'll ask you to pause the video right now. And if you tried this one, I will, similar to the other shape, not totally work it out, but I'll get you what it should look like and then a final answer. So for this one, your base, that's this side right here. The triangular ones are a little more tricky. That's 4 inches, and this is 3.5. And that's important because this is the base and this is the height. So area of the base is 4 times 3.5 divided by 2. And then your other 3 sides are these long, skinny-ish triangles, and those have a base of 4 and a height of 7 8/10 inches. So you're going to be doing the base times the height divided by 2, but you have to triple that because there's 3 of those faces. And all together for a grand total, if you added and multiplied and divided correctly, you should get 53 8/10 square inches as your final surface area for this triangular pyramid. Anyways, happy Monday. Rewatch any part of the lesson that you need, ask questions, do your best, show your work. A lot of you have been doing great with showing your work and your steps. I appreciate it. Also, the question has been, can I use a calculator? Definitely. Feel free to use a calculator, but also make sure with that you're showing whatever work went into these problems. Just like I did. This is enough work to show where you got that final answer. Anyways, good luck. See ya next time.